Değerli katılımcılar, İzmir Ekonomi Üniversitesi Sürdürülebilir Enerji Yüksek Lisans öğrencilerinin Sayın Yardımcı Doçent Doktor Mehmet Efe Bireselioğlu tarafından yürütücülüğü üstlenilen ileri düzey araştırma projelerinin sonuçlarının gerçekleşeceği 3. ve son oturuma hepiniz hoş geldiniz. Şimdi oturumumuzun moderatörü İzmir Ekonomi Üniversitesi Rektör Yardımcısı Sayın Profesör Doktor Cemali Dinçer hakkında kısa bir bilgi sunmak istiyorum. Sayın Profesör Doktor Cemali Dinçer, 10 yıl Bilkent Üniversitesi'nde çalıştıktan sonra özel sektöre geçerek İzmir'de Yeni Asır Gazetesi'nin genel müdürlüğü görevini yürütmüştür. Ayrıca 2006-2007 yılları arasında İzmir Hava Yolları Genel Müdürü olarak görev yapmıştır. 2002 yılında İzmir Ekonomi Üniversitesi'nde önce MBA programında lisansüstü dersler veren Profesör Doktor Dinçer, İzmir Ekonomi Üniversitesi'nde önce İletişim Fakültesi'nin, daha sonra Mühendislik Fakültesi'nin öncesi olan Bilgisayar Bilimleri Fakültesi'nin kuruluş çalışmalarında dekan olarak yer almıştır. İzmir Ekonomi Üniversitesi'nde Türkiye'de ilk defa lisans düzeyinde yazılım mühendisliği bölümünü kuran Profesör Doktor Sayın Cemal Dinçer, bilgisayar mühendisliği ve yine Türkiye'de ilk defa eğitime başlayan Endüstri Sistemleri Mühendisliği bölümünü, ardından Elektronik ve Telekomünikasyon Mühendisliği bölümünün kurulmasında da rol almıştır.
Şimdi Sayın Profesör Doktor Cemali Dinçer'i sahneye davet ediyorum. Hemen ardından 4 farklı proje grubunu temsilen Sürdürülebilir Enerji Yüksek Lisans öğrencilerimiz Merve Çevik, Eftal Pehlivan, Esra Onater, Alpan İbrahim Yetmen, Seray Toker ve Ufuk Yaman'ı sunumlarını yapmak üzere sahneye davet ediyorum. Alpan yapmıyor mu? Alpan yapmıyor mu?
Welcome to the last session of this conference. I was so excited that I wanted to jump into the stage. I didn't want to miss any time. Therefore, I'm sorry. Anyway, in this session, İzmir University of Economics Graduate School of Social Sciences, Sustainable Energy Master of Arts students will present their findings of their research projects. And I have gone through these 4 projects before coming over here, and I have a bad news for them because I am already teaching statistics. Therefore I will ask lots of questions on regression. Anyway, now we have 4 groups over here, and the first group, their project EU 2020 targets effects on the energy import dependency by Ecem Algun. Merve Çevik and Eftal Pehlivan. Ecem is okay. Oh, what is the model over here? You are presenting and she is answering the questions. Okay, okay. You shared some workload with me.
Yes.
Okay. Then Eftal will present. Ecem, you start. No, Merve. It's all confusing.
So let's start. Greetings, dear our guests. Firstly, I would like to express my feelings that it's a big honor of us to host you in İzmir University of Economics to discuss the sustainability of energy right now. We are very excited and kindly appreciated for the chance given to us to share our study with you, to the very sophisticated people in the energy sector. Personally, I really hope to be colleagues with each of you in the future and procure a remarkable knowledge here today. Now we would like to inform you about our research topic, where we tried to analyze the European Union's 2020 targets and its effect on energy import dependency, taking macroeconomic factors, GDP and population as the moderators. To give a brief information about our topic, we are going to focus on the 2020 targets first. It was the first time that European Union policymakers were agreed on a single energy policy. In order to meet with the sustainable future targets, in March 2007, targets were established and three main objectives were included. Those objectives were 20% reduction of EU's greenhouse gas emission according to 1990s level, 20% increase in the gross final energy consumption produced by the renewables, and 20% improvement in the European Union's efficiency. So, establishing a single energy policy by fostering the renewable energy share in power generation was the heart of the long-term policy making of European Union, because in 1970s it was understood that politically unstable regions were holding the supply of fossil fuels and the rich reserves. This political gift, this geographical gift also, given to the supplier countries, procured them to make a dominance to the demander ones. In order to prevent this ban and the consequence, I mean using the energy as a political weapon, with Lisbon Treaty, European Union was able to highlight the importance of security of supply, competitiveness, and the sustainability. Each member state has a binding target which is set individually for each country from the combination of renewable potential and the GDP. This chart enables us to see the progress of renewable target in each country according to 2010's data. In 2005, the EU's overall target used to be 10%. However, it was increased cumulatively 10% more, and it reached 20% by, it's expected to reach 20% by 2020. Since each country has their own renewable share targets, Estonia, Latvia, Lithuania, Romania, Sweden have already reached their targets. This means that other ones should also focus on to reach their targets, because they might be punished if you do not get the targets. Mostly Belgium, Denmark, Ireland, France, Luxembourg, Malta, Cyprus and UK needs to struggle their boosting renewable targets. And now this graph will help us to form an opinion about the energy import dependency of each country based on 2010's data again. Except Denmark, the rest are highly dependent on the energy import. Moreover, Belgium, Ireland, Cyprus, Lithuania and Malta are the most dependent ones. In overall, this dependency is a great threat for all European Union countries. Since there are several other factors affecting the energy dependency, setting a specific target alone does not necessarily help countries to achieve their main targets. Therefore, in our study, the moderating effect of GDP and population on the impact of 2020 targets on energy import dependency will be analyzed. Mentioning the macroeconomic indicators, GDP and population are expected to be increased. But why? Let's focus on them. The reports and research that Eurostat has published and the literature review that we made recently argues that the population of European Union is expected to be declined. Since they are getting older and there is no sufficient baby boom generation, they will face with a decrease in their native European population. Moreover, the higher life expectancy and welfare level may increase the lifelong time of Europeans. Estimating the long-run scenarios, the European Union is expected to encounter and there will be lack of the labor force due to the old population, and they are expected to tolerate on their strict mitigation rules. Foreseeing the increasing population due to the mitigations in the long run, European Union is likely to demand more energy, since population, energy demand and energy dependency are parallelly moving. Let's focus on the GDP. It is easily investigated that investing on domestic renewable energy sources will help country to have cheaper energy prices, and this will enable them to be competitive in the business. Estimations on medium and long run foresees that European Union is likely to increase its GDP by securing its economy from the macroeconomic crisis effect that they are facing now. Their GDP in total is expected to grow by 2.2% in average up to 2030, taking a part in the energy sector on construction, energy intensities, industry and efficiency technology sale. In order European Union to introduce themselves to the global energy market, since they can never be the suppliers, European Union needs to procure semi-goods or innovations to sustain their economic future with competitive energy prices. Now my teammate Eftal will focus on the research methodology and the regression model we did.
Thank you, Merve. So, dear our guests, welcome to our presentation again. So here our research methodology. We use the data set right from the 1990 to 2010, and the data is taken from the World Bank, UNFCCC database and II-4. And in our study, multivariate regression analysis is used. And as you see, we have three models here. In the first model, we run the model without moderating effect. And in the second model, we run the model with the moderating effect of GDP. And in the third model, we run the model with the moderating effect of population. So here are our regression results. As you see in the first line, without no moderating effect, the relation between renewable share and import dependency is negative. However, when we put the GDP and population to regression model, the relation between renewable share and import dependency change from negative to positive. And this case is the same for the the relation between greenhouse emission and import dependency. On the other hand, the relation between energy efficiency and import dependency without moderating effect is negative. And when we put GDP and population to the regression model, the relation between them doesn't change. However, the moderating effect of population on the impact of energy efficiency on import dependency is insignificant due to T variable is less than 0.005. So based on the low versus high GDP and population, we created 4 scenarios in order to understand whether 2020 targets are really worth for European 2070 countries to achieve. And here are the GDP scenarios. In the first graph, you see the relation between renewable shares and energy dependence. In high GDP countries, it cannot seen there, but it can be seen here. The blue line shows the high GDP countries, such as Netherlands, France, Italy, UK, Spain, and Germany. And we see that while renewable share is increasing, energy dependence increasing too. So it's due to the economic growth rate is greater than renewable growth rate, which means energy demand is more than renewable production. On the low GDP scenario, you see with the red line, such as Malta, Cyprus, Estonia, Latvia, and Lithuania, while renewable share is increasing, energy dependence is decreasing due to meeting energy demand by using renewable energy production. And here we see the graph that shows greenhouse gas emission and energy dependence relation. In high GDP countries, while greenhouse emission is increasing, energy dependence remaining same. Although greenhouse emission increases as well as vehicle ownership and energy consumption rises, greenhouse gas emission, the relation between greenhouse gas emission and energy dependence is less coherent. On the other hand, at low GDP countries, while greenhouse gas emission is increasing, energy dependence decreases due to meeting energy demand by using renewable energy sources. And on the last graph for GDP population, we see the relation between energy efficiency and energy dependence. In both cases, as you can see that while energy efficiency is increasing, energy dependence declines. However, when we check detail in the graph, you see the decline in high GDP countries is more sharper than low GDP countries, which could indicate that in high GDP country there is more attempt to use energy efficient applications in the countries. So here are our population scenarios are coming. In high population countries such as Australia, Poland, Germany, Spain, France and Italy, in high population countries, while renewable share is increasing, energy dependence is increasing too. Due to the positive relation between population and energy demand, the more people live in a country, the more energy is consumed. And since energy consumption more than the level of energy that produced from renewables and indigenous sources are not enough, it makes countries to more dependent on imported energy. And in the second graph, in high population countries, while greenhouse gas emission is increasing, energy dependence remains same due to the energy production from indigenous sources satisfy the growing energy demand, but that's why it prevents the increase in import level, but it augments the greenhouse gas emission in the atmosphere. On the other hand, at low population scenario, we see that while greenhouse gas emission is increasing, energy dependence is decreasing due to utilization from indigenous sources meet with energy demand at low population countries. And as I mentioned previously, that the relation between energy efficiency and energy dependence are not significant, but I would like to show that in both cases, whether high population and low population, while energy efficiency is increasing, energy dependence decreasing. So here are our overall results. In high GDP and in high population countries, increase in renewable share is not sufficient to decrease energy dependence. And in any case, energy efficiency presents negative correlation with energy dependence, which also indicates the essentiality of energy efficiency in sustainable development. And a reduction in greenhouse gas emission is not assist to decrease energy dependence. Hence, although greenhouse gas emission target was set for the combat with climate change, it obstructs the decline in energy import dependency. So what my conclusion is that it is not possible to make precise estimations without considering the macroeconomic differences, factors. And in our study, it indicates that GDP and population levels influence the purpose of 2020 targets. So, thank you for listening to us. If you have any questions, we would like to answer them.
Okay. I think it is time to remind that since we have 1 hour and 15 minutes for all 4 presentations, each presenter should limit their presentation 15 minutes and 5 minutes for questions. That will be fair enough for all groups. Therefore, any question for the first presentation? Anyone? Okay. Okay, the question is, what is your criteria for high and low population, I believe, and you have suspected that Australia is included in the high population?
We take the high population and low population with the level of the from the data set, and these are the numbers which are the highest one. Just the highest one, not the others, just the highest one, and at what level it is not sure in here. But if we need to make a forecast for a country, we need to put their data inputs as a dependency level, population level, GDP level, in order to make a good estimation. This is just the overall of the countries. Yes.
Eftal, stay over there.
Okay.
I need to intervene as an engineer. Whenever you use a graph like this, don't forget to put the label of the axis as well as, for example, what does 4D represent over there versus minus 200 on the next chart. What is that? What does it show?
Yeah. So it shows the energy dependence in somehow.
Dependence measured on what?
So I need to show the regression model, but maybe we can.
Yes,
do
stop
here.
over there. That was the second question that I would ask. Whenever you use such models, you assume that over here linear model, by the way,
Yes.
anyway, but this is the expected values, estimated values, and the actual values should include the errors, and you need to make assumptions regarding these errors, normal or not, whatever. You need to put everything over there.
Yeah,
For presentation purposes, you can use shorter notations,
Yes.
but
Yeah.
in your report, you must include everything over
In
there.
our report we have edits, but because of the time limits and to make the audience to clear in their minds, we just put the basic model. I mean, showing
And
the
in the next
parameters.
slide, okay.
This?
No, the previous one.
Okay.
Whenever you say the negative means not significant,
No.
positive means significant, or negative means negatively correlated, positive means positively correlated.
Yeah, correlation.
What is the difference than significance and correlation?
So the correlation could be negative and positive. Here, when renewable share is increasing, in the first line it says that when renewable share is increasing, import dependencies decreases. So it's a negative correlation. But there, of course, T variables are not here. Just I put the red line in order to show that this is not significant.
Okay,
So
when
because
you
the T
talk
variables
about the correlations, it's
lower.
better to, for example, if your model, this correlation assumes that your model over there, what does on the previous one, beta 1 that? Yeah.
Yes.
What does beta 1 talk about? What does it show? What is beta 1?
It shows the coefficient of the target on the equation. So it shows its power. It's just a regular analysis.
In order to talk about true dependencies, correlations, significance, you need to run tests on that value. That would show whether the true dependency or independency of the variables exist or not. Otherwise, if beta 1 is significantly not different than 0, then this will tell you nothing.
So actually, on this graph, the signs of negative or positive are taken through the B1 variable, or yes, in the first one is B1. If it's negative, we write negative.
Beta.
In the second one, we check the B3's coefficients or the sign, and that's why
Linear
we put
models.
positive.
All these are linear on the. Okay. Yeah, the actual values.
Yeah, the actuals are not here.
Yeah.
But we have it actually.
Okay. One last question.
Do you have real-life examples for your model?
We just worked on a theoretical, but if we could say that for example, in the second graph here, while greenhouse emission is increasing in low GDP countries, it is really can be seen in real life that the Malta or the countries who have indigenous sources like coal will, of course, choose to use them, to benefit from them. And regarding this, the greenhouse gas emission is increasing, but their energy dependence will be prevented to get higher, more, if without using the indigenous sources. We could just see in some the real shows, but exactly we just focused on the theoretical way.
Okay, I think we need to stop over here because we don't have sufficient time for the other groups. Thank you.
You are welcome.
Okay, the next research project, does carbon dioxide emission stands as an indicator for economic development? Evidence from OECD countries. This is the co-work of Esra Onater, Seçkin Sekman, Alpan İbrahim Yetinen, will be presented by Esra. Onater. You have 15 minutes for presentation. You'll leave 5 minutes for questions.
Okay. Welcome to our presentation, dear our guests. As you see, the topic of our study is Does Carbon Emissions Stands for an Indicator for Development Evidence of OECD Countries. Since Industrial Revolution, energy is most important factor that influencing economic development in the world. As countries developed and globalization concept formed, energy demand increased. On the other hand, worldwide climate change and disruption of environment accepted the existence of global warming and tried to find, On the other hand, worldwide climate change and disruption of environment began to affect human life. IPCC, UNFCCC, Kyoto Protocol argued and accepted the existence of global warming and tried to find solution to this problem. According to Energy Information Administration, 82% of world energy supplied by fossil fuels. Here, first chart shows that also 83% of energy supplied from fossils in OECD countries. It's a really remarkable point. It's easily seen that world still depends on fossil fuels, and the consequence is that carbon emissions keep pollute nature. And it's also remarkable that in 2011, overall carbon emissions released by OECD countries, the ratio is 41%. When we look for literature to check what have been done so far, we realize that the indirect relationship between carbon emissions and economic growth accepted and analyzed empirically over past 2 decades. However, results are ambiguous and controversial. The first perspective focuses on the relation between economic development and environmental pollution. This perspective based on environmental Kuznets curve hypothesis and claims that as country becomes developed in terms of increasing income per capita in early times of its growth, also environmental degradation increase as well until a threshold, and after this rising stops and it becomes to decline. Grossman and Krueger was pioneered this typical inverted U-shape hypothesis in 1991. Second perspective is more traditional one and focus on a joint relationship between energy growth and output. This perspective claims that these two determined jointly, not individually. The argument that higher energy consumption leads higher economic development and only higher economic development may use energy efficiently. Last perspective focuses on both economic development, environmental pollution, and economic development output. Combination of these two perspectives is to study relationship between economic development, energy consumption, and environmental pollution. That's all. Here, in our study, we used autoregressive distributed lag methodology, which is developed by Pesaran and Shin in 1999 and Pesaran et al. In 2001. We aim to find a relationship between carbon emissions, energy consumption, GDP, nuclear and alternative energy consumption for OECD countries. Here, CO refers to carbon emissions per capita, EC refers to energy use per capita, Y refers to GDP per capita, Y squared refers to GDP per capita squared, and ALT refers to alternative and nuclear energy use. I want to say that the positive sign of Y and negative sign of Y squared gives us an evidence the existence of environmental Kuznets curve hypothesis. There are 3 steps of ARDL methodology. First step is bound test to find if there is a co-integration among variables or not. The second step is long-run coefficient estimation,
And the last step is long-run coefficient and error correction term estimation. I want to state that ARDL methodology have several advantages rather than more traditional co-integration methodologies like Engel, Granger, or Johansson. Firstly, here there is no order of integration problems for levels and first differences. Secondly, different optimal lag lengths can be chosen for each variable. And lastly, ARDL model gives us more reliable results in small samples, minimum of 30. Here you see the general and ARDL model that we used. Before moving to the test results, I want to give you a brief information about our data set. Since production is the source of economic growth for countries and energy is the source of production, we choose OECD countries because all OECD consists of both developing and developed countries. Unfortunately, Estonia, Iceland, Czech Republic, Poland, Slovenia, Luxembourg, and Slovak Republic dropped from analysis because of lack of data. Also, Germany also dropped from study because Germany includes integration of order 2 variable. All variables drawn from World Data Bank of World Bank, except carbon emissions. Carbon emissions data set is drawn from BP Statistical Review of World Energy 2012. And the range of annual time series data for countries is selected according to availability. Now we move to the test results. According to bound test results, the right-hand side table shows the countries that have long-run co-integration between carbon emissions, GDP, energy consumption, and nuclear and alternative energy use. You see the data range, optimal lag lengths, ARDL model, and their F statistics. We cannot find any evidence that Austria, Belgium, Canada, Chile, Finland, Greece, Hungary, Mexico, Netherlands, and Switzerland in long-run relationship among those variables. Second and third step here as follows. The result of first equation gives us the long-run coefficient estimations, and the last one gives us the short-run coefficient estimations and error correction term. According to test results, we find the evidence that Australia, Denmark, France, Israel, Italy, Portugal, and Turkey gives us an evidence that those countries fits the environmental Kuznets curve hypothesis. On the other hand, Japan, New Zealand, Norway, Spain, Sweden, United Kingdom, and United States does not fit the environmental Kuznets curve hypothesis. Lastly, Korea has pure positive relationship between GDP per capita squared, and energy consumption. And lastly, there are two stories behind environmental Kuznets curve hypothesis. As countries developed, how they reduce their carbon emissions. First, they may use more expensive and more advanced clean energy technologies to reduce those carbon emissions. Secondly, they may move their heavy industries to underdeveloped countries. The second one is like win-and-win situation. In one hand, underdeveloped countries increase their GDP levels. On the other hand, developed countries increase their quality of air. But it should not be forgotten that this moving process do not reduce carbon emissions, but it only moves the carbon emissions another part of the world. In conclusion, we can say that reduction in carbon emissions does not an overall indicator for all countries. Some countries like Japan, New Zealand, or Korea keep their emissions increase. Thank you for your attendance. And I'm glad to answer your questions.
Thank you, Teresa. And we will have questions now. Actually, she saved us some 5 minutes. Thank you. Okay, the questions.
So I'm sorry. Sorry. So my name is Simona Marinescu, and I represent UNDP global center for private sector in development. So obviously there are lots of assumptions that are behind regressing dependency between GDP and carbon emission and population, so all those parameters that you took into consideration. But it's interesting, it's very interesting. So it always comes with interesting results as regressions are made to reveal certain links that you otherwise would not see. So are you publishing that? Or is this going to be made, you know, available to people to read, or is just an internal exercise?
We hope it's going to be published, and as Eftal say that since we have time constraint, we cannot include our short run or long run coefficient estimations, but they are all studied in detail in full paper, and it's going to be published, we hope.
All right, so that's
for your
it's just for
question.
our interest. As I think no matter the level of errors involved, you still learn a lot from any type of regression among macroeconomic parameters. Thank you.
The qualitative conclusions, I learned too much. These curves, the countries, but could you please go back to that complicated natural logarithms equations? What did you understand over there? What is this? Who understands this?
This ARDL model based on optimal lag lengths, these are
Okay.
more dynamic ones.
Go to your first model. I will have some.
This one?
No, this is the linear
No, this is-
logarithmic. Yes, this one.
Just to represent what we are going to do. This is a quadratic relationship, and we just want to show carbon emissions are going to explain by energy consumption, GDP
Yeah,
per
yeah,
capita,
I
etc.
understand that. Your representation, by the way, is the correct one, including the error term over there. And you're assuming that carbon emission is linearly affected by energy use per capita, also linearly affected by ALT, alternative and nuclear energy, but quadratically affected by GDP.
Yes, the result, the coefficient of GDP per capita squared.
Yeah,
I
I
mean,
understand
alpha
that.
tree.
What I am trying to emphasize, if you go to the next page,
Next,
yes, no,
this,
stay over there.
okay.
Interpret this. What is this? What
This
does it tell?
This is general ARDL model. This delta terms,
For example, the second line, what does it tell?
second line. Okay.
Sum of what?
Sum of natural logarithm of energy consumption.
Differences. There's
Of
a
course,
delta
of
over
course,
there.
Of course, difference of 2 in time t to time s.
For all legs up to m
Yes,
of whatever. If you are using something, you better know that.
I know, but you know.
It's too complicated, by the way. You don't need to put these all complications over there because these are models that you are using, but you are interpreting qualitatively good. Your results that I can understand. But whenever you go over there, then someone asks questions that easily confusing everything. Thank you.
Thank you very much.
Okay. The next is the next project. How will already existing and emerging oil powers affect OPEC's role? I am not illiterate, but somehow someone crossed out some words over here. I am not easy to read. And the project will be presented by Seray Toker over there, and joint work with Evrim Özyorulmaz. Whoever, okay, Evrim.
Good
Go
afternoon,
ahead.
dear guests. Welcome to our presentation again. I am really honored to present our project within this workshop, and our project is titled as How Will Already Existed and Emerging Oil Powers Affects OPEC's Role. Among both fossil and renewable resources, oil has still main characteristic and it still preserve its dominant position with its largest share. As the world economy and policy mostly shaped by oil, it is significant to know oil production and export capacity of major oil exporting countries. That's why we choose Organization of Petroleum Exporting Countries as a subject. However, as we all know, the world in a process of energy revolution. That means there are new kinds of resources, both conventional and unconventional resources, such as pre-salt oil of Brazil, Canadian tar sands, and shale gas of the United States. And all of these developments will change international oil trade in a considerable extent. That's why, in light of these developments, we assume that the future of OPEC does not seem as bright as in the past. And these graphs show the historical trend of proved oil reserve, which increased continuously over the years. And the most remarkable jump has been experienced from the year 1998 to 1999. And the main reason of this development was the discovery of the Canadian tar sands. Actually, today OPEC continues to preserve its privileged position among the oil market, thanks to its more than 80% of the proved oil reserves. And among the member states, Venezuela has the highest share, and it's followed by Saudi Arabia and Iran. And global oil consumption is an increasing trend, like global oil production. And when we look at the distribution production among OPEC and non-OPEC, it has three different phases. Until the 1980s, OPEC has dominant position, but just start beginning of the 21st century, non-OPEC has increased its production, and today both OPEC and non-OPEC countries are contributing to the oil market in terms of production equally. That's why which led us to the question of future of OPEC. And when we look at the oil production of OPEC members, Saudi Arabia has dominant position. The blue line indicates the production of Saudi Arabia, and it's followed by Iran and United Arab Emirates. However, in the former slide, the main actor was Venezuela. In terms of oil production, the main actor is Saudi Arabia, but when we look at the oil resources, the main actor is Venezuela. And now I am going to give a brief information about the history of OPEC. The organization was founded in 1960 in order to prevent the lowering crude oil prices by the alliance of major oil companies known as Seven Sisters, which are Chevron, Mobil, Texaco, Gulf, BP, Shell. And the founding members are Iran, Iraq, Kuwait, Saudi Arabia, and Venezuela. Later, other oil-rich 9 countries has joined the organization, which are respectively Qatar, Indonesia, Libya, United Arab Emirates, Algeria, Nigeria, Ecuador, Angola, and Gabon. However, the organization currently consists of 12 members, excluding Indonesia and Gabon, because these two countries are no longer considered as a net oil exporter by OPEC. And these charts show the fluctuation in oil prices. Actually, a series of political and economic events has increased the importance of OPEC, starting from the Yom Kippur War in 1973. At that time, OPEC has increased the oil prices around 70%, and it put embargo on pro-Israeli countries. And in the recent literature, studies can be categorized under 3 headings. On the one hand, there are some studies which are focusing on political aspects, that OPEC use oil as a weapon or not. On the other hand, other part of the studies are discussing that whether OPEC acts as a cartel or not. And thirdly, there are some studies which are discussing the future potential of oil with new resources, new technologies, and new developments. Despite the huge share of OPEC, as I mentioned at the beginning of the presentation, the world in a process of energy revolution. Therefore, I am now going to focus on the new developments, especially in the oil sector. And when we look at the Arctic region, this region presents a significant feature for oil. The size of the Arctic is almost same as the African continent, but most of the Arctic is oceanic. And Arctic region is allocated among 8 countries, which are Canada, Denmark, Finland, Iceland, Norway, Russia, Sweden, and US. However, as Sweden and Finland, as shown in the figure, Sweden and Finland do not have border with Arctic Ocean. These 2 countries do not have claimed any jurisdictional rights in the Arctic region, and Iceland also has withdrawn its activities in 2008 because of the huge economic costs. Therefore, it's possible to say that at present there are 5 countries which have overlapping and disputed claims in the region, excluding Finland, Sweden, and Iceland. Arctic region holds 13% of the world's undiscovered conventional oil resources and 30% of the natural gas resources. Although there are a number of problems in the Arctic region, such as clashing sovereignty interests of member states, environmental consideration, or high expensive exploration and drilling technologies, the region presents a significant feature for oil. Another significant country is Brazil. According to Energy Information Administration, recent discoveries of large offshore pre-salt oil deposits could transform Brazil into one of the largest oil producers in the world. And these resources are named as pre-salt oil because these petrochemical resources are found under the salt layer of the ocean. And Brazil has discovered its first pre-salt oil deposit, the Tupi field, in 2007, and since then the largest oil discoveries in recent years have come from Brazil pre-salt basins. According to Petrobras, the Brazilian state-owned major oil company, the pre-salt oil activities have already become feasible both technically and economically. That's why the pre-salt oil developments are accepted as historical milestone for the oil sector. And another significant country is Canada. Actually, Canada is a remarkable producer of both conventional and unconventional resources, which makes the country as a net energy exporter. According to Energy Information Administration, the oil sands account for approximately 98% of the Canadian oil reserves, and this makes the country second after Saudi Arabia. As an energy export country, Canada exports almost all of its energy to the United States. And as we all know, United States has recently announced that it will be a self-sufficient country by 2035, thanks to rising production of shale gas and fuel efficiency. Therefore, the huge potential of Canadian export will be directed to the world market, which can create a big threat for the future of OPEC. And another country is Norway. International Energy Agency estimates that 47% of the Norwegian reserves wait for extraction. And the significant point is that Norway has reached an agreement with Russia in 2007 on their maritime boundaries in the Barents and Arctic by resolving their 40-year-old disputes. And with this agreement, Norway has gained an additional continental shelf, and we assume that as both Norway and Russia have common interests, the cooperation also seems possible between these 2 countries. And as we all know, Russia has by far the largest natural gas resource of the world, and it is the second country in terms of oil production after Saudi Arabia. But the main problem in Russian energy sector is overboosting, and Arctic regions seems as a good solution for this problem. And that's why in 2007, Russia planted a deep sea flag at the North Pole and showed the significance of Arctic region to the whole world. Actually, the largest oil and gas resources of the Arctic region are discovered in Russia, and it has 43 large oil and natural gas deposits. Although Russian government has ratified the Kyoto Protocol, it's not likely to take any constraining measures about environmental considerations. Actually, it has two major Arctic projects. And another country is United States. As I already mentioned,
Better to be last country.
Yes.
It is the last? Okay.
No, one more time.
You have already consumed your presentation time, therefore.
Sorry. And US already explained that it will be self-sufficient by 2035 thanks to rising production of shale gas and fuel efficiency in the industry and transportation sector. Actually, the country already has been a shale gas revolution, but the important point is that this shale gas revolution will create spillover effect in the oil sector. Actually, we already witnessed the lowering LNG prices recently, and the last country is Venezuela. Venezuela holds the largest proven oil reserves of the world, and like Canada, it is also supply most of the energy needs of the United States. And according to Oil and Gas Journal, in 2007, Venezuela had 99 billion barrels of proven oil reserve, but in 2011, country had reached 211 billion barrels of proven oil reserve with the inclusion of massive resources of extra heavy oil in Venezuela's Bernico Belt. However, the country has significant political problems, but we assume that if Venezuela can achieve a politically stable environment after Hugo Chavez, it will create main threat for the production of Saudi Arabia despite the OPEC, because there is no binding rule among the OPEC members. So it's possible to say that the huge amount of petroleum will be spread out to the world market thanks to the self-sufficiency of the US, because there won't be any import from Venezuela or Canada. And as conclusion, we assume three scenarios. OPEC could expand by merging with Western countries. It cannot change its position and become a competitor against new developments, or it can act according to the world conjuncture. However, when we take into consideration both conventional and unconventional resources with the potential of Arctic region, it seems that OPEC cannot be as dominant as in the 1970s, but it is also important to note that there is only one oil market still exists in the world. Thank you for your attention.
Okay.
And
Thank her, and I will take only one question because we are already lagging the time. One question over there.
Thank you very much. Thank you very much for this beautiful presentation. There is only one contribution that I want to make to this, I would say, hypothesis in a way, especially about the effect. And this goes on. I think one parameter is missing in your study. This is the cost of the production. And when you are talking about the Arctic region, you know, the cost of the production, especially from the deep sea, is nothing to do with the OPEC countries, and also especially the petroleum, other kind of petroleum production countries. And we can say also we can produce petroleum if you have reserves in Turkey, but can we commercialize it? This is the problem because of the cost of production. So if you put this parameter also, then for the competition and for the evaluation and the benchmarking of the two big players in the world market, this will bring another insight, and according to me, it will be much more complete in this term. But thank you very much. I'm enlightened a lot. Thank you very much.
Thank you. It was a good point, though. Okay.
can I add something?
Yes.
Thank you for your contribution, first of all. I completely agree with you, but as technology increase rapidly, the developments in the Arctic region will be feasible, because already developments in the Brazil has become feasible both economically and technically, and we assume the future of OPEC, so the future potential of the world, and in the future we assume that it will be costly effective for the future.
As you said, it is just assumption.
Yes.
Thank you. One last question, because we are lagging time. Okay. Okay.
Thank you, Sarai, for this really comprehensive presentation. I just wanted to add that in your final presentation, please also take into consideration that OPEC is not only an economic organization, it's also a political organization. It has a political and ideological stance. So in that context, not everything can be explained in the economic context. OPEC, when it is trying to find a stance, it will probably take into account how it will position itself towards the Western countries, towards the developed countries. That may also has an effect. Please take that into consideration. Thank you.
Thank you. Good comment. Okay. The last project, the effects of increasing use of renewable energy in electricity generation on electricity prices, presented by Ufuk Yaman and shared work by also Özge Şenyüz, whoever. Okay. Özge. You have 15 minutes for presentation. Okay. This time I
can even shorten you to help you. So welcome, first of all. I am planning to give you a brief presentation of our research about the effect of increasing renewable energy usage on electricity prices. Beforehand, I have planned to give you an introduction of the energy issues worldwide. However, today you have already heard these things several times. So, for the sake of not boring you, I would like to skip these steps. Yes, as you know, we all know what the renewable energy is, and we also know that government puts incentives to increase its share on the generation. However, nowadays we are also hearing bad news about renewables, which takes out the incentives from the picture, such as the last law published in Spain, reducing the promotion from 20 euros to 0. Yes, so many politicians and economists claim that the increasing share of renewable electricity generation has an increasing effect on electricity prices, and we would like to investigate if this statement is true or not. After reviewing literatures on similar topics, we have seen that there are many studies from different countries made on the same subject, and I want to show you only 3 of them. And first one is made by Fraunhofer Institute in Germany in 2008. So this study investigates the effect of the renewables in German market, because German market is known to have a higher share of renewables. And as you can see from the graph, the renewables has a decreasing effect of the spot market prices. Therefore, the other generators such as coal and natural gas are forced to reduce their sale prices, and therefore, even in 2006, the support payments for renewable electricity generation compensates the amount that is paid by the consumers as incentives. So this is a positive effect of renewables. And there is also 2 other studies, and first one actually concludes that the Dutch electricity price remains to a large extent related to the natural gas fired power plants, and the third one is made in Spain, and it's actually accepts that renewable has a increasing effect on electricity prices. However, it fails to consider the other benefits of environmental and socio-economic ones. In our research model, we use an econometric model and statistical analysis to identify the functional relationship between the energy usage and electricity prices. As you can see, we have chosen 11 countries, and those countries were chosen by the longer history of renewables and also the availability of the organized data, especially for electricity prices. And the period we have taken is from 1991 to 2010. So we have taken a composite measure to be able to make a comparison between countries with different profiles. I just wanted to point out that in our case, actually, renewables are unconventional renewables, which means renewables except hydro, because hydro nowadays considered to be a conventional energy resource, and it's really well used in all over the world. And if I come up to our first finding, we have seen that the renewable energy has an increasing effect for all countries. As you can see, 11 out of 12 countries shows us a positive impact. And if I want to interpret these figures, for the Greece case, 1% increase on unconventional renewable usage causes a 0.5% increase on electricity prices. So the result is yes, there is an increasing effect. However, we had a confidence limit for our regression model. So we have chosen the countries which resulted higher R-square values. So in this case, so then we remain with the 4 countries that is higher than our confidence limit, which are namely Belgium, Denmark, Ireland, and United States. For the countries where R-square is low, other factors are considered to be in effect, such as conventional generations, fossil fuels, population, GDP, or economic crisis, energy crisis. So these things are considered to be also have an effect. And we also want to check if our assumptions are correct. And then in a second scenario, we have included GDP, population, energy crisis, economic crisis, and fossil fuel shares to our model, to our simple regression model. And we have seen that after including these extra parameters, all countries are passing our confidence limit. However, the dominating effect of additional factors changes the impact of unconventional renewables. As you can see from the below graph, the figures, the impact values are not the same as the first analysis. Therefore, we lost the reliability of the second analysis, and then we decided to continue with the first method. So we have left with 4 countries: Denmark, Belgium, Ireland, and United States. As you can see on the first figure, the bars are representing the effect of unconventional renewable generation on prices, and the line represents the share of unconventional renewables on electricity generation. So the share for Denmark is the highest one, and the impact is the lower there. So there is an inverse relation between the share and the impact, as we can say, and it's actually in reality logical. And in time, if you increase your share, you can increase your know-how, and you can use it more efficiently. You can use the technology more efficiently. And also on the second picture, these data is taken from the International Renewable Energy Agency reports. This figure gives us the onshore wind power system installed costs for different countries. Belgium was not available, so sorry for not including that one, but it is also confirming our findings in the first graph. And furthermore, we also want to see whether the effect of learning curve, so there is an idea of learning curve for electricity generation, for technologies, for all technologies, and we want to investigate if there is a learning curve effect on electricity prices as well. So we divided the time series into 2 periods, first decade and second decade, one until 2000 and one after 2000. So, but we can, as you can see from the figure, the impact for the first period is negative. So this is due to extremely low share of renewable usage. So the regression model cannot catch the actual effect, because before 2000 the actually known costs of renewable generation is higher than today. So, but for the current, so for the next decade, second decade, we can say that the impact is positive for Germany and Spain. And even we cannot comment on the learning curve effect. As the market grows and new companies with less know-how enters the market, the average cost of generation will increase. And Chinese wind turbine manufacturers are the biggest example. They have approximately half of the European competitors, the cost, but so the generation, the equipment cost are almost half of the European competitors, but many investors experiencing higher unit costs during the lifetime of the wind farms due to high operation and maintenance costs. So as a conclusion, I have actually three bullet points that I want to tell you. So yes, there is an increasing effect of unconventional renewable energy usage on electricity prices, and the effect varies on different countries because of different system costs, because of different know-how capabilities. However, other factors such as GDP, population, energy and economic crisis, as well as the fossil fuels are more decisive on most cases. Thank you very much for listening. I would like to hear your questions if there is any.
Thank you. Now we'll take the questions. Okay.
Sorry if my question is silly. I also studied economics, but it's been a long time.
I'm an engineer, so
oh, okay, great.
Yeah, you might know the models better than me.
So in your model, when you're looking at whether there's a relation between the cost of electricity and your unconventional energy uses, right? It makes sense by logic. And then you said that in where your R squared was low, it's related to certain effects such as economic crisis or perhaps other variables, right? Or factors, right? So when you look at the data set in general for the unconventional energy uses, this is a very silly question perhaps. It's not my area of expertise, by the way, but for instance, certain countries have more wind energy or more solar energy than others. So how were you able to reflect that in your analysis?
Actually, first, we have also investigated them separately, but so some countries have higher wind potential, yes, and they use more wind than others, and some might use solar as well. Yeah, you are right about that. But so we actually investigated the effect in general for each country. So
how did you do that? Did you take like a norm?
So we put in the regression model. I can show you. So this is the first model. So the dependent variable is electricity prices, and there are two independent variables only, and the first one is the share of unconventional renewable energy sources. So we put together wind, solar, and some of it, yes, together. So the share in general, and that's actually why you had a good point there, because that's why we have different impacts in different countries. So some countries are using cheap resources, some countries are using solar more and waste more, so that is even more expensive and causing a higher impact. But we take the share of renewables in general, in total.
Okay, please go ahead.
Yes, my question is about the different prices of electricity, because you have different prices if it's spot or if it's long term. You have different prices if it's peak electricity, which is the most valuable.
Yes.
And for instance, if you have your peak electricity in summer and you have solar energy, and so the air conditioning is very strong, the solar electricity lowers the price of the peak electricity. Do you have that sort of detail?
No, we don't have. We just use the rough values. Yeah, this analysis actually explains the one that I mentioned from Fraunhofer Institute. It's actually explaining that effect, but our methodology is not that sensitive.
Okay, please go ahead.
It's a kind of continuation from the question over there regarding the electricity prices. Ufuk, I assume that these prices are wholesale prices, yeah?
It's yearly industrial prices for
I think it's a
industrial
wholesale,
usage. Yes.
When I see the levels, it's 9 cent, euro cent, so it should be, I think, wholesale prices.
It's also before taxes. So the The
yes,
tax values are
yes.
not included there.
That is what
Yeah.
I assume it must be wholesale prices. The comment I want to make is maybe you may better reconsider your conclusions before that. What I wanted to say is that some of the countries, because you're making an evaluation on the prices of electricity and how it is affected by the renewable generation, yeah? What is the effect on renewable generation? Some of the countries, for example in Germany, the additional cost of renewables are directly added on to the end consumer price, which means not the wholesale price, but end consumer price.
Yes.
It's like a levy, it's like a fee on the end consumer. So you may have missed that in the meantime, or your model doesn't take that into account. But just for your information, if you wanna, I think it's also in all the feed-in tariff countries charge the additional renewable prices on the end user, end consumer.
Mm-hmm.
So you may have checked that.
Yes, sir.
Okay, any other question? Right in the back.
Thank you for the presentation, and thanks to all presenters. I have a simpler question, actually. What I realized that Italy was the only exception in your findings in terms of the
negative effect.
Negative effect.
Yeah,
did you have any evidence that why that happens in this way, or would you use, or would that data provide any insights for your further research?
Yes. So after that slide, I actually explained that only 4 countries are passing our confidence limit. So Italy is already below our confidence limit, which indicates that we cannot trust the impact calculated for Italy. Therefore, even if it's negative, it's for our standards, it's not included on the final countries. So. Why from a country perspective? Yeah, so yes, actually, yeah, Why, yeah. So, yes, so we just, actually, we didn't go into detail and investigate each country's policies and general position. We just actually assumed that there are other factors in effect. But yeah, we didn't go in detail and define those other parameters for each individual country. Yes, so actually this analysis, this research could be made further and improved.
Okay, thank you. One question over there. Okay, I'm sorry I couldn't see you. You are on the almost out.
Actually, my question has nothing to do with the presentations made here. My question will be, some people debate that economics is no longer a social science as it relies more and more on mathematical and statistical tools to explain the things. What do you think about that?
Me.
You're asking these questions to an engineer.
Okay. So economics. Thank you very much for the other corner. Can we talk about wind or renewable? I can explain you the incentives in Turkey or in the world, other countries. Actually, yeah, I'm not in a position to actually judge that statement. I'm an engineer.
Better to talk about the joy of life.
Sorry.
To me? To me? Okay, I would make a general comment on that anyway. Then you raise that question. Thank you very much. You can sit down. Now,
Thanks all.
thank you. First, I would like to emphasize that those 4 presentations were perfect. We need to applaud them. Secondly, I would make a final comment before your question, whether you have asked or not. Now, we use models, engineers, social scientists, economists, whoever, making some field study and based on the assumptions. He made an assumption. I can criticize that, but he put his assumptions over there and supporting with his model and using some data from some sources, whatever, to come up to some meaningful conclusions, okay? Whatever we do, we start with the assumptions, models, and observations, compare the observations with the model, theoretically whether it's correct or not, use some criteria, R square, whatever, whether our assumptions are correct or not, eliminating some and going on. And I suggest that whenever you use observations, field data particularly, it is not 2 by 2 is equal to 4. We can, with our own mathematical system, I can tell that 2 by 2 is equal to 4. And no one over here can claim the otherwise unless the numbering system, it's binary system, there is no 2. Therefore, unless you change the system, the statements are perfect. Conclusions are true for everyone. But whenever we use the observations, samples, and make some conclusions about populations, we must be very careful. Because the conclusions that we arrived at supported by only those observations. And rather than using some concrete sentences like, we have seen that, it is proven that, we must be very careful over there. We must rather use the statement, data supports or does not support our conclusions. That's the final word that I would say. Now, the next, you will call him, okay.
Sayın Rektör Yardımcıma ve çok sevgili öğrenci arkadaşlarımıza konuşmaları için, sunumları için teşekkür ediyoruz. Hemen ardından İzmir Ekonomi Üniversitesi İşletme Bölüm Başkanı Sayın Profesör Doktor Serdar Özkan'ı Çalıştay'ın değerlendirmesini yapmak üzere kürsüye davet ediyorum.
Thank you very much. Finally, I'm on the stage. Actually, first of all, I would like to congratulate our students for their presentations and studies. According to me, the most important part of a research study is creating the question, research question. When I look at those research questions they try to answer are very interesting. So the models may change, the research methods may change, the data may be criticized, but the questions are welcome. They were all right. So we can say that in our university, our students are developing good questions in energy, politics, geography, and many other topics are included. So thank you very much for their contributions. Well, actually my speech was 50 pages, then shortened to 20, then now 12. Okay, distinguished guests, ladies and gentlemen, it's a great honor to host such an event on sustainable energy, and I would like to thank to all partners for their contributions to this event, valuable contributions. And of course, another thanks to the organizers that invited me to make this wrap-up speech. As the head of Business Administration Department, consistent with the topic of the theme of the event. And of course, another important thank to Ms. Deniz Öztürk of United Nations, she helped me. Yeah. She helped me while I was building my speech in order not to lose the UN's view and to add UN's view in my speech in a proper way. And this is important because this will be the official declaration of this event, so UN's view must be put in a proper way. Well, since this wrap-up speech will be an official declaration, my speech will focus on the general view of UN Sustainable Energy for All initiative, what we heard today from distinguished speakers, and of course, finally, key messages to all partners of the initiative. As we all know, sorry, I'm going to read that, it will be written maybe. As we all know, United Nations Secretary General Ban Ki-moon has repeatedly stressed the critical importance of sustainable energy and is mobilizing key constituencies from all sectors of society in a major global initiative intended to shape the fundamental policy and investment decisions needed to put countries on a more sustainable energy pathway over the next 2 decades. This new global initiative launched last year, Sustainable Energy for All, will engage governments, the private sector and civil society partners. The initiative has 3 major targets by 2030. Achieving universal access to modern energy services, improving energy efficiency, and increasing the share of energy generated from renewable resources. The Sustainable Energy for All initiative calls for all partners to take bold action through strengthened enabling policy, transformative partnerships, and collaboration, enhanced financing, and new innovation. As we see, all partners have a role to play. The initiative will seek significant new commitments and policy changes at the government and national level. Additionally, it encourages the private sector to derive investment, increase innovation in products and services, and increase operational efficiencies. To do this, it is imperative that executive leadership in the private sector commit to the initiative and make access to energy, energy efficiency, and renewable energy as a strategic priority across their organizations from the boardroom to the facility level, and preferably by making these a part of their strategic plans. From his enjoyable and highly energetic speech, we heard from Brice Lalonde on how business can contribute to sustainable development, in particular with regards to environmental stewardship. Since there are only 4 companies joined to the Caring for Climate initiative, we hope that more Turkish companies will join in the near future. We heard from Dr. Yılmaz Argöden on the UN Global Compact Turkey's sectoral deployment and the work done to date in partnership with local chambers of commerce and other strategic business organizations. This innovative approach supports this framework. He also made the message on the call to business to support the Secretary General's initiative in advance of the governments of Turkey to join. We are delighted that they intend to advance the SE4A goals for business and to localize this across Turkey in partnership with its strategic partners through their outreach and advocacy activities. We also heard from Accenture Turkey on the joint study conducted with the UN Global Compact that resulted in the formation of 19 industry reports. I checked some of them and they're very interesting, and it's possible to access them on the internet. We hope that these can be utilized by the Turkish business community. We heard from UNIDO Turkey and the UNDP Istanbul International Center for Private Sector in Development on what they are doing in this area, and we hope that more companies in Turkey partnership with such organization to advance broader development goals. And fortunately, we heard some great company examples from different industries, mainly from Tesco Kipa, Royal Haskoning, Sedefet members such as Sütaş, Oyak Renault, Tüpraş, Akçansa, GDF Suez Turkey, İskent, Egegaz. We hope that following this initial launch in Turkey that more companies will support the SE4A initiative and become leading advocates of environmental stewardship. Consistent with the theme of the event, there are some key messages to business community in Turkey as well. As mentioned today, the business case is clear on how business case support the UN Secretary General's initiative on sustainable energy for all through four main areas. In other words, there are 4 ways companies can implement the identified actions in a manner that is aligned with core business strategies and creates value to advance the 3 objectives of sustainable energy for all, as I mentioned in the beginning of my speech. Businesses can transform their operations through increased energy efficiency and the use of renewable energy alternatives. Businesses can innovate and modify their core products and services to meet the new and developing market demands for more energy efficient products, sustainable energy, and the infrastructures needed to extend energy access around the world. Businesses can identify ways to establish a strategic link between social investments and their core strategies to increase the likelihood that such activities will be sustained and able to reach scale. And businesses can seek to engage governments, national, international, regional, or local, on relevant issues that protect competitiveness and drive opportunities while working toward the objectives of sustainable energy for all. I'm the head of business administration department, so any topic is much more meaningful if I can link them to profit, money. So, in order to increase the understanding of the contributions of these actions on the value of businesses, we can take into account that companies may increase their revenue, this is important, by creating new business models, collaborating to develop new markets, developing new products and services, and maybe moving from products to services. And companies may decrease their costs by improving energy efficiency, streamlining supply chain and logistics, reducing raw material consumption, and changing operations to reuse waste. And companies may enhance brands by showcasing innovation, collaborating to increase transparency, improving community involvement, and engaging stakeholders. And finally, companies may manage their risks, which is very difficult for Turkish companies because risk awareness is very low in our culture, by contributing to policy agendas, protecting license to operate, integrating risk management activities, and diversifying business model and operations. As you see, revenue, cost, brand enhancement, and risk management, these 4 important points. Even though this event mainly focuses on the actions to be taken by the business community, we are all sure that all partners have a role to play. So, thus, please let me summarize some of the key messages to other partners. For example, key messages to municipalities, civil society, and academia I have here. We also heard examples of what role local government cities like the Bornova municipalities are doing in this area. This is critical, especially for emerging markets like Turkey. There is a window of opportunity for new investments and projects to be sustainable while also benefiting citizens with the aim of a better quality of life for all of us. Finally, we heard some concrete examples on what role universities and other academic institutions can play in this area. As İzmir University of Economics, we are proud to have opened Turkey's first sustainable energy division. As a proactive organization that provides cutting-edge education and career development, we seek to equip future leaders with necessary analytical skills and know-how to compete in the international area and changing global economy. And moreover, we should also consider the research potential of these organizations, universities, as a witness that our students made good with their advisors. We are one of the 18 universities in Turkey that is signatory to the UN Global Compact, and we find that academia has an integral role to play in advanced sustainability principles in partnership with all stakeholders. Now, here are the public policy recommendations to the governments, especially the Turkish government, by the way. This conference, co-organized with the UN Global Compact Türkiye and İzmir University of Economics, aims to shed light on the public policy recommendations made to government on the topic of sustainable energy and environmental stewardship at the Rio+20 UN Conference on Sustainable Development. Today, we make note again and share our support to the following recommendations. Although the private sector must be involved in developing and adopting solutions needed to address climate change and energy challenges, there is also a need for long-term and effective legislative and fiscal frameworks to create a stable price for carbon and support and motivate private sector actions. Without the proper enabling conditions, progress by the private sector may be difficult to achieve. In order to create conditions necessary to scale solutions and achieve proposed targets, here are some of the recommendations we heard today. Advanced policies and mechanisms intended to create a stable price for carbon through international measures, including trading schemes and tariff reductions on energy efficiency and renewable energy technologies. Consider of the end of all subsidies to fossil fuels and reorient subsidies towards clean and renewable energy, including activities such as loan guarantee programs for ensuring access to sufficient capital for renewable energy companies, measures to stabilize the long-term price of power from renewable projects, and policies to encourage the adoption of transformative low-carbon solutions. Develop, implement, improve, and harmonize technical standards in critical green areas such as transportation, housing and energy consumption, including renewable energy portfolio standards, and mandates renewable fuel standards and efficiency standards for building, appliances, vehicles, and other energy consumers in line with international standards to provide both stability and certainty for future biomass electricity generation and transportation fuel use, and encourage more efficient construction and products. Integrate energy efficiency, renewable energy, and clean energy criteria more fully into public procurement. Establish long-term national energy plans to create stability and predictability and to reduce the risk for companies making long-term investments. Establish city-level ordinances, for example, to encourage the use of renewable and uptake of energy-efficient technologies. Implement other energy pricing measures, including critical peak pricing or peak time rebates for electricity, externality pricing with respect to renewable energy, and long-run marginal cost pricing for electricity in energy-poor areas. Ensure that government action on climate and energy is sensitive to the social dimension of sustainable development, including addressing potentially adverse impacts on already marginalized groups and encouraging the participation of all relevant stakeholders. And ensure that any future sustainable development goals, which can be found on post-2015 development agenda, include targets on access to energy, efficiency, and renewables. In summary, we voluntarily organized this conference to shed light on the opportunities and challenges for business, not alone, but in partnership with the UN system, civil society, local governments, academia, media, and other important stakeholders. We know that the government of Turkey is considering to join the SE4A initiative in advance of these. Today we sought out to present the business opportunities to the broader public. This is a new topic. Most companies, unfortunately, in Turkey are not even aware of the UN Secretary General's goals on sustainable energy for all. And energy is only one dimension of what is needed globally by all actors for the way forward to ensure the sustainability of Mother Earth and the well-being of future generations. However, it's a very important dimension. This is perhaps one of the main messages we take back today. Thank you very much for your attention.
Sayın Profesör Doktor Serdar Özkan'a görüş ve değerlendirmeleri için teşekkürlerimizi sunuyoruz. Programımızın bu bölümünde kapanış seremonisi gerçekleşecektir. Şimdi Sayın Kamal Malhotra'yı ve kendilerine hediyelerini takdim etmek üzere Rektör Yardımcımız Sayın Cemali Dinçer'i ve Sürdürülebilir Enerji Anabilim Dalı Başkanım Sayın Yardımcı Doçent Doktor Mehmet Efe Bireslioğlu'nu sahneye davet ediyorum. Sayın Kamal Malhotra'ya ve Rektör Yardımcımız Sayın Cemal Dinçer'e teşekkür edip kendilerini yerlerine uğurluyoruz. Şimdi Sayın Biris Lalondu ve kendilerine hediyelerini takdim etmek üzere Rektörümüz Sayın Profesör Doktor Tunçtan Baltıcıoğlu'nu sahneye davet ediyorum.
Hediyelerini takdim etmek üzere diğer katılımcılarımızı, Çalıştay katılımcılarımızı sahneye davet ediyorum. Sayın Doktor Simona Marinescu,
Sayın Hakan Ümit,
Sayın Roy Van Esten,
Sayın Ahmet Eren Öztürk,
Sayın Sezer Türktan,
Sayın Sefa Targit adına SEDEFET Genel Sekreteri Sayın Emre Tamer,
Sayın Doktor Saltuk Düzyol,
Sayın Doktor Sırrı Uyanık,
karıştım.
Değerli katılımcılarımıza katkılarından dolayı tek tek teşekkür ediyoruz. Şimdi Sayın Rektörüm ve Sayın Anabilim Dalı Başkanım, bu organizasyonun gerçekleşmesine büyük katkı koyan işbirliğimiz UN Global Compact New York Ofisi Türkiye temsilcisi ve Türkiye Baş Danışmanı Sayın Deniz Öztürk'e hediye ve katılım sertifikasını vereceklerdir. Sayın Rektörüm ve Sayın Rektör Yardımcımı yerlerine uğurluyorum ve Sayın Anabilim Dalı Başkanımı bir süre daha sahnede bekletiyorum. Şimdi yüksek lisans programı öğrencilerimize katılım sertifikalarını takdim etmek üzere İşletme Fakültesi Dekanı Sayın Profesör Doktor Can Mugan'ı sahneye davet ediyorum. Şimdi sırasıyla sevgili öğrenci arkadaşlarımı sahneye davet ediyorum. Eftal Pehlivan, Merve Çevik, Ecem Algun, Alphan İbrahim Yetmen, Seçkin Sekman, Esra Onater, Seray Toker, Evrim Özyorulmaz, Ufuk Yaman ve Özge Şenyüz. Şimdi Sayın Dekanım ve Sayın Anabilim Dalı Başkanım bu yıl mezun olacak Enerji Yönetimi ve Politikaları sertifika programı öğrencilerine katılım sertifikalarını takdim edecekler. Sevgili öğrenci arkadaşlarımı sahneye davet ediyorum. Zeki Onur Demirkan, Sinem Katrancı, Vildan Demirkıran, Ozan Koca, Turan Gümüşkesen, Belemir Gizem Taneli. Şimdi Cemali hocamıza ve Serdar hocamız derste olduğu için onun adına Dekan hocamıza sertifikaları takdim edilecektir. Şimdi ise yüksek lisans programı öğrencilerimizden Sayın Evrim Özyorulmaz'a Sayın Anabilim Dalı Başkanımız sertifikasını takdim edecek.